Hello everyone. Today we're gonna talk about isotopes and ions and how do we tell how many particles are in each of the isotope and each of the ions. So let's start with isotopes. Isotopes are the atoms of the same element that have a different mass number. Remember, the mass number is what should be different, right? So how can we get a mass number different from the other atoms? They should have different number of neutrons. So isotopes are the atoms of same element that have different number of neutrons. So let's do an example. So we are going to talk about the isotopes of carbon. Carbon has atomic number 6. Now the atomic number always tells you the number of protons. So atomic number is equal to the number of protons in the atom, right? So let's start. Now we have carbon 12. This is how we represent an isotope. We write down the name of the element, then this little dash here, and then we write down the mass number. Right, so this is what we call an isotopic notation. This is how we write the isotope, right? So let's count the number of particles in each of those isotopes of carbon. Now since carbon has an atomic number of 6, so the number of protons would be 6. Since we have all the same carbon atoms, right, they only differ in the mass numbers. So each of the carbon atoms should have 6 protons, right? Because the number of protons is specific for a certain element. You cannot change them. If you change the number of protons, you end up in a new element, right? For example, if we have nitrogen, nitrogen has 7 protons because its atomic number is 7. Right? Now let's count the total number of electrons. Since the atom does not have a charge, it's a neutral atom. So for a neutral atom always has the same number of electrons. So number of protons is always same as the number of electrons. So electrons would not change in an isotope. Isotope still has the same number of electrons. So all the electrons are 666, right? Now let's talk about the neutrons. So isotopes are formed if you change the number of neutrons in the nucleus of an element, right? So now let's see how many neutrons would each of those isotopes will have. Now how do we solve for neutrons? The number of neutrons is always equal to mass number minus atomic number. Mass number is represented by A and atomic number is represented by symbol Z, right? So we can also say it's A minus Z, right? Now let's solve for the number of neutrons for carbon 12. Carbon 12 has a mass number of 12, so that would be 12 minus the number of protons, so that would be 6, right? And now carbon 13 has a mass number of 13, so the number of neutrons would be mass number minus atomic number, so that would be 13 minus 6, and that is 7. Right? And let's solve for the number of neutrons in carbon 14 isotope. So number of neutrons would be atomic mass number minus the atomic number, which is 6. That would make 8 neutrons, right? Now you can see all of these isotopes have a varying number of neutrons. So it's the number of neutrons that make an isotope of an element. Next, we are going to start with ions. So let's talk about ions now. Now, what are ions? Ions are still the atoms of same element, but this time we have a different number of electrons. So ions are made by changing the number of electrons in an atom, right? So let's see that. So we're going to take example. First example is sodium atom. So sodium atom has an atomic number of 11. The symbol is Na, right? So since we have atomic number of 11, it will have 11 protons. So there are 11 protons, right? And you can draw 11 positive charges, right? And now let's count the number of electrons. Since there is no charge on the sodium, it's a neutral atom, the number of electrons should also be equal to 11, same as the number of protons. And you can draw 11 minus charges, negative charges, and you see all of these are balanced, right? Same number of positive and negative charges, they balance out. So the net charge on the atom is 0, no charge. So this is what we call a neutral atom, right? And this is how we represent a neutral atom. Now let's talk about sodium ion. Sodium ion still has 11 protons because the symbol is sodium, is still the same type of element, right? And it has 11 positive charges that cannot change as long as we are talking about sodium, right? Now let's count the total number of electrons. Now see, there's a charge of +1 on the sodium atom, right? So it means there is an additional positive charge, meaning one of the positive charges was not balanced by the number of electrons. So it should be 1 electron short, right? So there should be 10 electrons, right? Always remember, if there is a positive charge on the element, then the number of electrons is less than the number of protons, right? So now look, this positive charge is not balanced because there are 10 electrons. 10 negative are balancing 10 protons, 10 positive charges. So that additional proton was left unbalanced, right? So that will stay as a positive charge on the atom, and you will write the symbol of sodium atom with a positive charge, and that is how we write down the symbol of the sodium ion. Let's do another example. We're going to talk about fluorine atom now, right? The atomic number of fluorine is 9. It means it has 9 protons. So 9 protons, right? So if there is no charge on fluorine atom, this is how we write the symbol, meaning it should have the same number of electrons, that is 9, and all the positive and negative charges balance out, right? So the number of protons and electrons are equal when you don't see any charge on the atom. We call it fluorine atom, right? Now let's talk about the fluoride ion, the ion formed by fluorine, right? Fluoride ion has a charge of -1. This is how we represent the symbol. This is the symbolic representation of fluoride ion. So how many electrons do you think? Since there is an additional negative charge, meaning 1 extra electron that is not balanced by the 9 protons, right? So we have an additional negative charge that is not balanced. So whenever you have a negative ion, there should be more electrons when there is a charge of negative charge on the neutral atom. When there is a positive charge, it means there are less electrons compared to the number of protons. Right? So that additional negative charge stays on the fluorine atom, and we write fluoride ion in this symbolic form. That's the symbolic form of fluoride ion. So if it has 9 protons, there should be 10 electrons, an additional electron that will stay as a negative charge on the fluorine atom. That's it. So hope that video is helpful. Thank you.